With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question on continuity and differentiability. So here in this question we need to prove that the function, that is the f of x is equals to cos x, is a strictly decreasing function in the interval of 0 to pi, which is an open interval on both ends. And similarly this function f of x is a strictly increasing function in the interval of pi to 2 pi in the open interval. And similarly we need to prove that it is neither an increasing function nor an decreasing function in the open interval 0 to 2 pi. So now for understanding this question, we should understand the meaning of the strictly decreasing function and the strictly increasing function. So let us first consider that what is the strictly increasing function. So suppose we have a function f of x and we are talking about in the interval of the a to b, which is an open interval. So this function f of x would be an increasing function, that is a strictly increasing function in this interval if this function, the functional value of this function always keeps on increasing in this interval a to b, and f dash x should not be equals to 0 at any point. So this f of x is increasing function, this is an increasing function when f of x2 is always greater than the f of x1, where the x2 is greater than x1. And along with this condition we should also have the condition that the f dash x should not be equals to 0 in the range of the a to b. So f of x2 should be greater than f of x1, that is the functional value of the function when x increases should also increase, and the derivative of that function should not be equal to 0 in the range of a to b. And similarly we can say that this function is a decreasing function. This is a strictly decreasing function when the f of x2 is always less than the f of x1, where the x2 is always greater than x1, which means that if we increase our x on the number axis, then the functional value of the function should always decrease. So as we move ahead on the x-axis, the functional value should always decrease. Then we can say that the function is a decreasing function, and along with this we should also have one more condition, that the f dash x should not be equals to 0 at any point in the range of a to b. So now for discussing this question we have to draw the graph of the f of x is equal to cos of x. So let us draw the f of x is equal to cos of x graph. So let us first draw the y-axis. So here let us say that this is our y-axis, and similarly we have the x-axis like this. So this is our x-axis. Now the x-axis represents the x and the y-axis represents the functional value, that is f of x is equal to cos x. So here we have to draw the graph of the cos x. So the graph of cos x looks something like this. So here we have roughly drawn the graph of the y is equal to cos of x. So this is the graph of y is equal to cos of x, and here the x is 0, and here we have the x as pi by 2, and here we have the x as pi, here we have the x as 3 pi by 2, and here we have the x as 2 pi. So this is the complete cycle of cos x from 0 to 2 pi. Now let us consider the first part of the question. So in the first part of the question they have given us that this function, that is f of x is equal to cos x, is a strictly decreasing function in the interval 0 to pi, and that is an open interval. So now we are looking for the open interval 0 to pi, that is the both points 0 and pi are not included in our set. So we are looking from this point to this point, and here we have this region as an included region between these 2 points. So in between these 2 points it is given that the cos x is a decreasing function. So let us check. So here we can see that as x increases, the functional value of x always decreases. So if we consider this point, so at this point we can see that the functional value of x is this, But now as we have increased our x to this point, so at this point we can see that our functional value of x has decreased. So as we are moving to the right and increasing our x, our functional value is decreasing. So as we have learned above that, this is the property of the decreasing function. So here we can see that this type of trend is following from the 0 to pi. And along with this, we have also learned that the f dash x should not be equal to 0. So here we have the f dash x is equal to 0 at x is equal to 0. And we also have the f dash x is equal to 0 at x is equal to pi. But both of these points are not included in our solution set because we are given the open interval 0 to pi. So we can say that this is completely following the property of the strictly decreasing function. So we can say that in the open interval 0 to pi, this f of x is equal to cos x is a strictly decreasing function. Now let us focus on the second part. So the first part is true. Now in the second part, they have given us that it is a strictly increasing function in the interval pi to 2 pi. So here if we consider the pi to 2 pi, that is this range. So in this range, they have given us that this is a strictly increasing function. So now according to the property of strictly increasing function, as we move to the right on the x-axis, as we increase our x, our functional value should also increase. So here we have, suppose if we consider this point, then at this point we can say that our functional value of x is this. But if we move towards right and if we move to this point, then at this point we have our functional value as this. So we can clearly say that the functional value has increased as we have increased our x. So as x increases, the y has also increased. So this is the property of the strictly increasing function, and we can see that this type of trend is followed from the interval pi to 2 pi in this complete range. And along with this, we should also check that the f dash x should not be equal to 0. So we can see that at x is equal to pi, the f dash x is 0, and at x is equal to 2 pi, the f dash x is 0. But we are looking in the interval from pi to 2 pi, where this is an open interval and both pi and 2 pi are not included. So here we can conclude that as x increases, the y also increases. And we can also say that the f dash x is not equal to 0 in this complete range from pi to 2 pi. So this is a property of the strictly increasing function, and hence we can say that in this range from pi to 2 pi in this open interval, the function is strictly increasing. So this second option is also correct. But now in the third option, they have given us that this function is neither increasing nor decreasing in the range 0 to 2 pi. Now here we have proved that in the range of 0 to pi, this function is strictly decreasing. And here we have also proved that in the range from pi to 2 pi, this function is strictly increasing. So we consider the range 0 to 2 pi, then in this range, the function is also increasing and the function is also decreasing. So we can say that the function is neither increasing nor decreasing because it has to maintain the same trend along the complete range, but it is not maintaining the same trend. It is increasing also and it is decreasing also. So we can say that the option C is also correct, that is, it is neither increasing nor decreasing in this range 0 to 2 pi. So this is also correct. And this is our solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.